Hello, my name is Tom Fries with One Stop Systems, and I'm going to tell you today about Rigel, which is our flagship AI transportable supercomputer. Rigel was designed with the most stringent military and aerospace requirements in mind to ensure that it can provide peak performance for your harsh edge computer applications. Rigel allows you to use the most powerful NVIDIA GPUs available in your rugged edge applications. Rigel is made up of a server motherboard combined with the NVIDIA HGX A100 4GPU board, which is called Redstone. And in addition, there is a UBMC that I'm going to talk about more later. There's also available PCIe slots that you can use for FPGAs, NVMe drives, or NIC cards to provide a flexible configuration for you. In addition, Rigel has redundant power supplies, which I'll tell you about more in a moment. Okay, let's take a more detailed look at Rigel. So there are three levels to Rigel, and we're going to start with the bottom layer here, which is the power layer, and it's made up of N+1 54-volt output power supplies that provide power. Up here you can see these red and black cables to the NVIDIA Redstone board, and there's also N+1 12-volt output to provide power to the rest of the system. The middle layer is made up of server motherboard, which is a PCIe Gen 4 motherboard with an AMD 7003 series EPYC processor, and also an OSS designed UBMC board, which stands for Unified Baseboard Management Controller. The top layer is made up of the NVIDIA Redstone board, which I mentioned earlier, that has 4 SXM4 A100 GPUs. And over here, we also have an OSS designed midplane board. The midplane board provides PCIe lanes directly from the motherboard, which I mentioned previously, up to the Redstone board, and is the PCIe switch fabric for the Rigel system. And in addition, it has 4 available by 16 Gen 4 PCIe slots. This is the NVIDIA HGX A100 4-way GPU board I mentioned earlier, that's also known as Redstone. And as you can see, this board supports 4 SXM4 based GPUs. Now this is what that SXM4 based GPU looks like. This is actually the older version SXM2, but it gives you a really good idea how different the form factor is from the traditional PCIe GPU. So this is a mezzanine type GPU that goes directly onto the board. Now the other feature with this system is there's NVLink between all 4 GPUs. So that's giving you approximately 50 gigabytes per second bidirectional between the GPUs. One of the unique capabilities of this board is it has NVLink between all 4 GPUs. And that gives you total aggregate of 2.4 terabytes per second. The SXM GPU requires a heatsink on it, and this is the custom heatsink that OSS designed specifically for Rigel and specifically to support the SXM4 GPU on Rigel. So let's talk about the ruggedization design for Rigel. Rigel is made out of a lightweight aluminum frame, as you can see here, extends around, up and down. And the system was designed to mil standard 810G for jet aircraft engines to ensure they can stand the shock and vibration requirement for that environment. In addition, it has a mil standard 461E for electromagnetic interference. Rigel is, you'll notice, is approximately a half rack wide, which means you could actually put 2 Rigels next to each other for increased performance. You could also put another OSS half rack wide system, whether it be for more storage or even additional PCIe cards that you want to attach to Rigel. I mentioned before the custom heat sinks. The custom heat sinks allow us to extend the operating temperature range for the NVIDIA GPUs. In addition, these are ruggedized as well to the A10G requirements so that you can ensure that the heat sinks are going to stay on the system despite the shock and vibration it may have in the operating environment. There's also structural bracing throughout on Rigel to mitigate low frequency resonance. Rigel is an air-cooled system. You can see that below we have fans to cool down here, and then we have larger fans on the top layer to cool the GPUs. These are counter-rotating fans, and it's probably hard to see, but the heat sinks in the two front GPUs are a little bit shorter than the two GPU heat sinks on the back. And this allows or ensures that fresh air will flow to the back GPUs to ensure that they can be kept cool. For environments where air cooling is not sufficient, One Stop Systems has developed liquid cooling options. The first, direct-to-chip liquid cooling, and then for the most extreme environments, immersion cooling. All components of Rigel are conformal coded to ensure that it meets all humidity requirements that you may need in your application. PCIe is a core competency of One Stop Systems, and in addition, we are an NVIDIA Tier 2 OEM partner and licensed to ruggedize around the HGX platform. Our One Stop Systems PCIe experience and NVIDIA authorization ensures that we design strong signal integrity into Rigel and ensure the GPUs perform at optimal capabilities. What are applications for Rigel? First is the intelligence, surveillance, reconnaissance, or ISR marketplace for the defense sector. The high-end, powerful A100 GPUs allow you to bring a tremendous amount of sensor data in, whether that be radar intelligence, images, data off of radio frequencies for analysis. And because of those power, these GPUs provide real-time analysis for operators. Another use case is the autonomous trucking marketplace, where a large amount of data needs to be read and analyzed by the GPUs. Again, because of the power of the A100 GPUs, it's providing real-time analysis on sensors that are providing input to the position of the truck versus traffic and weather conditions. Because Rigel was designed to mil-standard A10G, it is a flight-ready system, and it is also a system that can be used in mobile shelters, autonomous trucking, or any other environment where humidity is a consideration or there's going to be stress put on the system by shock and vibration. And now we are going to show you some features of the UBMC.
We're at the login screen of the OSS UBMC, or Unified Base Management Controller. The UBMC is included with our Rigel Supercomputer and will be standard on all future OSS system-level products. UBMC extends the traditional system management paradigm to support GPUs and PCI switched fabric functions, even if the host processor is in a separate enclosure. With UBMC, we provide a single pane of glass management of complex systems and an open-source Redfish API for easy integration with industry-standard management tools. In this demonstration, the Rigel Supercomputer with UBMC is running in our California headquarters, and we are connected to it over the Internet. UBMC itself is an embedded industrial temp processor that operates on system standby power, so it can function in adverse conditions and when the host may not be running. Access to the UBMC is secured. Login credentials are required. Users may be assigned one of 3 levels of access depending on need. Authentication may be local to UBMC or integrated with a remote authentication server. Here is the main dashboard screen. It summarizes fan, temperature, power supply, PCIe, and GPU operations. In Rigel, there are 4 NVIDIA A100 GPUs, and you can see GPU temperature sensors are graphed, and you can see the general temperature trend over the past few seconds. Here are the details about temperature, something of particular interest when GPUs are involved. You can configure this page using the drop-down menus to highlight specific areas of interest. The page configuration is saved across invocations for convenience. Back on the main dashboard, you have many additional options to choose from. Quick Links is an easy way to navigate to commonly used sections of the UBMC. One link here allows you access to the native BMC or management pages of the host. Here you can enter the same login credentials used earlier and directly manage the host or motherboard. While this direct access is convenient, we don't expect customers to use this much since the same information is provided on the UBMC dashboard and screens in an integrated presentation. The power of the Redfish API makes this all possible. Here is a little demonstration of UBMC in action. We will stress the 4 Rigel GPUs with an NVIDIA tool called GPU Burn. You will notice the real-time nature of the UBMC presentations as the GPUs warm up. You will also notice the GPU fans respond by accelerating. Also see that the host-related fans are unaffected. Finally, the UBMC is highly configurable. The network configurations, alerts, SMTP events, and other functions are all accessed from the settings screen. Over the network, UBMC responds to Redfish API requests as well as legacy IPMI tool inquiries. In the themes setting, the appearance of UBMC display can be changed to use a dark background. The UBMC is also responsive and will adapt to different display devices. This was a brief introduction to UBMC. UBMC with Rigel will be available this quarter, as well as OSS newly introduced Gen 5 4U Pro platform.